Hello everyone, my name is Lihwa. The title of this presentation is Matagorda Ship Channel and its entrances navigation efficiency for safety improvement through ASCERT and CMS modeling. My co-workers, Dr. Deepening and Dr. Shi, help getting together the slides here. The outline of the presentation is given as follows. First, background and objectives. Then, Matagorda Ship Channel Improvement Project, numerical models and settings, hydro and wave simulations, and finally, summary and conclusions. Background. The Matagorda Ship Channel, along the west shore of Matagorda Bay, is located on the Gulf of Mexico coast in Southeast Texas. The location is between larger Galveston Bay to the east and Corpus Christi Bay to the west. The ship channel extends approximately 26 miles from the Gulf side entrance to port of Point Comfort in the upper bay. It intersects the famous Gulf Intercoastal Waterway in the lower bay. The Port Authority and the USACE Galveston District have planned a ship channel widening and deepening project to accommodate larger cargo ships. Objectives include conducting numerical models, including ASCERT and the CMS models of waves, hydro, and sediment transport for the ship channel improvement project. And modeling new channel dimensions includes widened and deepened cross-section, new dredged material placement areas along the west side of ship channel, and expansion of the turning basin at the port of Point Comfort. This slide showing a little bit more detail of improvement plan. The channel width changes from the range 200 to 300 feet to the range 350 to 600 feet range. The depth changing from the range of 38 to 40 feet to the range 47 to 49 feet mean low water. This configuration exclude over dredging and advanced dredging. The figures to the right shows sample of the cross-section change. On the bay side of the channel, just entering the bay, the existing channel cross-section will be increased to about twice larger. And not only that, is shifted slightly to the west. The ASCERT model is a two-dimensional depth averaged circulation model using the finite element scheme on unstructured mesh domain. It runs more efficient on supercomputers with the MPI computational algorithm. It's more applicable for large coastal domain. The coastal modeling system is a two-dimensional depth averaged model system using the finite difference model scheme on rectangular grids. It runs more efficient on personal computers with the OpenMP algorithm. The CMS consists of two model components, CMS wave and CMS flow. CMS wave can simulate most common coastal processes we observed in the field. The CMS flow calculates hydrodynamics as well as sediment transport, salinity, and morphology changes. Both ASCERT and the CMS can be run under the surface water modeling system interface, SMS. The CMS is more suitable for local, smaller coastal regions. This slide shows an example of the CMS bathymetry and the domain applied in the present study. The offshore incident wave is based on NOAA NDBC buoy 42019 near Freeport, Texas, located approximately 120 miles east of the entrance of the Matagorda Ship Channel. This slide is showing both ASCERT and the CMS model domains. The ASCERT model provides boundary conditions to the CMS. The wind input to both models are based on NDBC buoy 42019. The surface pressure fields are based on UCAR and NCAR and the USAC hindcasting database. There are two major river flows, one's Colorado River and one's the Lihwa River. Both are based on USGS database. The NOAA and the USGS collect long-term water level and salinity data, but in our study, we are using more detailed, complete field collection information from 90-day period in 2005. This slide is showing many stations for the data collection. This slide is showing the example of CMS hydrodynamic results under the calibration. The figure to the left showing the water level comparison between model and measurements at the three locations. The high water level is caused by storm surge during Hurricane Rita. The figure to the right is an example of a comparison of model current results and the data at mid-bay station. This slide is showing example of model wave results and the data. Figures to the left showing wave height, period, direction, and the wind input information. The 5 subfigures to the right side, those are snapshots of a model wave field results. The wave direction really is depending on the wind direction blowing over the bay region. This slide shows an example of a flood and ebb current flow vectors field. The color is the water level magnitude. This slide is showing the example of model salinity results versus data at 3 locations. The model calculates more smooth the results, so it doesn't really reflect those strong variation or fluctuation of salinity. But in general, the model predicted the trend very good. We use the 6-month period for morphology change, sediment transport calibration. 2 surveys available. One is from September 2013, one's from February 2014. So model can closely mimic what happened to the sedimentation in the field. The modeling scenarios, we consider 5 flow conditions. 3 are the real cases. One is Hurricane Rita, once Hurricane Harvey in 2017, and the high river flow occurred before Hurricane Harvey in 2017 during February and March time period, and two hypothetical river flow conditions. One's medium, one's low river. The low river flow condition is more common in the Bay Area region. There are combination of 4 cases: water level and the channel configuration. This include the present water level without the project, means without the ship channel improvement project, briefed as PWOP. And the next is present water level with project, PWP. And next is future water level without project, is FWOP. And the last one is FWP, present future water level with project. The future water level is the 50 years projection of water level at 2074 from 2024. We expect the ship channel improvement project to be completed in 2024. The right side figure showing example of differences of maximum current speed from the model. This is for low river flow condition, and the differences is the future with project and the future with the project. Because of the timing, so I'm going to jump into the summary and conclusions. The USACE, ERDIC, the Engineering Research and Development Center, and the New Orleans District are presently assisting the Galveston District to investigate the Matagorda Ship Channel and its entrances, navigation efficiency, and safety improvement using the ASCERT and the CMS model simulations. ASCERT is run as the regional model to provide boundary conditions to the local CMS for the simulation of ship channel in Matagorda Bay. Modeling scenarios include the channel deepening and widening project to accommodate larger and newer container and cargo ships. Modeling hydro results show the ship channel entrance become more efficient for flow exchange with the project. Modeling channel shoring with project is to be conducted to add and support the future O&M planning with the ship channel improvement project. This concludes my presentation. Questions? Thank you.